Hello, welcome to your lesson on the sine and cosine rules. In the previous lesson we saw the sine rule. In this one we're going to learn a new rule called the cosine rule, and we're going to look at when to use one or the other. You will need your calculator, of course. Make sure again you are in degree mode. This is a big idea. These rules are a big part of trigonometry and geometry, so let's take some notes. Let's begin here. Well, actually this part we looked at already in the previous lesson, so don't worry about taking notes on this, but let's take a look to remind ourselves. We have a triangle. It is not a right triangle. So since it is not a right triangle, we cannot use the trig ratios sine, cosine, and tangent. However, we learned last time that if you draw a height line, which is perpendicular to the base, you create two right triangles. And using those two right triangles, we can do some work here with substitution and basically get to what is called the sine rule. So that was the last video lesson. We had the sine rule. It connects angles and sides of a non-right triangle. And it looks like this or like this. So now let's go a little further. Let's talk about the sine rule and the cosine rule. So the sine rule and the cosine rule, let's take these notes. So these can be used to find unknown sides or angles of a triangle when the triangle is not a right triangle. So that's the power of these. We are not limited to right triangles. So first of all, the sine rule, again, one more time, looks like this. We can write it with the side lengths on top or the side lengths on bottom. And we usually just use two parts to make an equation, not a triple equation like this. And the main thing in the sine rule is if you know an angle and a side across from it, then you can probably proceed with the sine rule. Okay, the cosine rule looks like this. So a little bit longer, a little bit more going on there. It has cosine in it here. And the cosine rule, basically, this version of the cosine rule can be used to find any side length. Because see, we have a side length here, like the a side. So a squared. So to get a, we can just do a, and then you can take the square root of this side and this side. So to get the length of one side, you can just take the square root of all that. But this is basically this cosine rule here. Okay, so that's how you find a side using the cosine rule. How do you find an angle? Well, there's another version of the cosine rule that looks like this. And basically, if you rearrange this formula and solve for cosine A, you will get to this place. So by moving all this stuff to that side, you get this. This then allows you to find an angle. So this was to finding a side, this is for finding an angle. And now to proceed with finding an angle, of course, you know when you have cosine of some angle, you're going to do A equals inverse cosine. So you got to do inverse cosine aside from that angle, solve for that angle, and we'll do inverse cosine of all of that. The most important thing to notice in the cosine rule is this, that here we have A and A. So if we have a side and an angle here across from it, in the formula, notice we have our side here and our angle here. So that's one way to remember it. It doesn't matter if those are called A. The triangle doesn't have to be ABC. The triangle can be XYZ. The point is, if you know an angle here, then this here that you're solving for is the side that is across from that angle. And then the other sides go in here. Okay, so that's the key for looking at cosine rule. And you see the same thing happening here. If you're looking for an angle, over here on this side of the equation, you need to know the side across from that angle, and then the other two sides go there. Because these ones you're adding, the order doesn't matter, but here you're subtracting that one. So it's important which one you're subtracting. So the one you're subtracting here is the one across from that angle that you're looking for. Okay, so here's a summary of that. No need to write all this down, but it's basically showing you that the cosine rule, as we saw, it can be written either with a squared first or b squared first or c squared first. Again, that's basically all that's saying is it doesn't matter which of the sides of the triangle you're solving for. As long as, again, you follow that rule. If you have a side here, we have cosine of the opposite angle there. Or if we have side b here that we're solving for, then we have cosine of b at the end here. Or if we have side c we're solving for here, then we have cosine of c there. That's all. It just means you can rearrange it any way you want. And finding the angle, there's the angle formulas. Again, we can be looking for any of the three angles. And the important thing here, again, is if we're looking for this angle, then the side we're subtracting here is the side across from it. And if we're looking for angle B, then we're subtracting B here. And if we're looking for angle C, then we're subtracting C squared here. Okay, so that's all. Just the order matters and the position of things you put in the formula matters. All right. if you are one of those students that needs to know where these formulas come from, because this cosine formula looks kind of interesting, where does it come from? Let's take a look. So here's a non-right triangle, which has been made into right triangles by putting a height line in it. And if this side was originally C, and now we call this length x, then this must be C minus x, because it's the entire length minus this piece. So now we have this triangle relabeled because of the right triangles we've created. Let's begin here. You can write Pythagorean theorem. X squared plus h squared equals b squared. So that's for this triangle. And you can solve that, rearrange it for h squared. Now do the same thing for the other little triangle. What's h squared going to equal there? So check your work there. We have c minus x squared plus h squared equals a squared. And then that rearranged for h squared is this, which can simplify into this when you multiply this out. Now, set your two h squareds equal to each other. So that piece must equal this because they're both h squared. So here, both those parts have been set equal to each other. That rearranged comes into this. And we can see we're almost at the cosine rule already. It's very close, except for the end here. There's no cosine. So how do we introduce a cosine? Well, we can do a cosine by doing cosine of angle A, and that equals x over b. And then that turns into x equals this. So this x can be replaced by that, and we have the cosine rule. That's where it comes from. Pretty great proof. All right, now next step. When do we use the sine rule? When do we use the cosine rule? Because now we have these two rules that help us find sides or angles in non-right triangles. So here's 5 non-right triangles, and I'm looking for the red piece. So here I want this angle, here I want this angle, here I want this side, and so on and so on. But how do I decide whether I'm going to use the sine rule or the cosine rule? Well, let me show you. So the sine rule is used if you know 2 angles in one side, or 2 sides and a non-included angle. So that's this. Let me show you these visually. So here we have a triangle where we know 2 angles and 1 side. That is called, okay, sorry. And here's one where we have 2 angles and a side as well. And this side is in between the 2 angles. Or if you have a triangle where you know 1 side, another side, and the angle here, which is called the non-included angle. It's not the angle in between. But when we talk about triangles, these things have names, and the names will help us remember these. So this one is called an AAS, means a triangle where we know the angle, and then a side. So that's an AAS triangle. So if we're given angle, angle, side, we can use sine rule. Or this one here, what's this one called? Well, this one is angle, side, angle. We know an angle, a side, and an angle again. So if we have that kind of triangle, we can also use sine rule. Or if we're given this information, angle, side, side. All right, that kind of triangle, we can use the sine rule. And we already saw this kind of triangle in the last lesson. When we have an ASS triangle, it leads us to what is called the ambiguous case, and there can actually be 2 possible triangles there, or 1 or 0, but often 2 triangles that meet that condition. All right, so that's the sine rule. Cosine rule, we use it when we have a side, another side, and the included angle, so the angle in between. So that would be called what? What would this be called? Well, let's take a look in a second. Or if we know all 3 sides. So if we know 3 sides, we're going to use cosine rule. So that's side, angle, side. This is side, side, side. So it's easier to remember, I think, these two, because SAS and SSS is very easy to remember. Side, angle, side, 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 side. If you have those 2 situations, you can use cosine rule. Any other situation, sine rule. Okay, so let's go back to these, and your job is to figure out, are we going to use sine rule, cosine rule, or what for these? So look at the first one here. What kind of triangle do we have? Okay, so first one looks like this. What do we have? Looks like side, side, side. And your job is then to decide, okay, side, 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 well, that was cosine, so I'll get you started. And here, don't solve it completely. Just set up the equation. What will it look like? Okay, so we have side, 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 and we know we're going to use this one because we're looking for an angle, not a side. And therefore, you can set up your cosine rule to look like this. Again, if we're looking for angle B, the one we're subtracting here has to be side B, the one across from it. Okay, then the other 2 sides go here, those 2. And then on the bottom, we have 2 times those 2 other sides again. So you begin with, okay, what angle am I looking for? And in here, you put the side across from that angle. And then fill in the rest with the other 2 sides. Pretty easy. This you should be able to punch in 1 step on your calculator. We won't do that yet, but you would basically do inverse cosine of all of this. Okay, next one. Decide what kind of triangle it is and whether we're using sine rule or cosine rule in one of its forms. Okay, this triangle was ASA. We have an angle, side, angle. Therefore, that's a sine rule, and we're looking for angle A. So set up something like this, sine rule, and you can put, oh, in this one you'll need to know the other angle, and when you know two angles, you can get the other one by subtracting from 180. And now you can set up sine rule. So A over sine of that angle equals 21 over sine of this angle, and then you can use that to solve for A. All right, I usually start by putting the thing I'm looking for right here, because again, sine rule can be written upside, like this flipped over, and this one could have been first, but I usually put the thing we're looking for here, the unknown, because now it's easy to just multiply by sine 32 over here. Okay, next one, decide what kind of triangle. Okay, this is ASS triangle, therefore sine rule, we're looking for an angle here, so I'm going to set up sine rule like this, sine of that angle over 8 equals sine of this angle over 10. Great, next one, what do we have? Okay, this is a AAS triangle, angle, angle, side. Therefore, we're going to use sine rule like that. And I set it up by putting x on top. X over sine 80 equals 7 over sine 60. Next one, what do you have? Okay, this one again, I see side, angle, side. Side, angle, side is one of the two we use cosine rule for. And here we're looking for a side. Therefore, we're going to use this version of cosine rule because that's a solve for a side. Now, when you set it up, if you're looking for B here, then the cosine at the end is going to be of the angle across from it, so cosine of 124. And then you fill in all the other sides here. So the one we're looking for, here's the two sides we know, here's the two sides we know, cosine of that angle. All right, now that you're familiar with when to use which formulas and how they work, let's try some problems. So these problems, some will require cosine rule, some will require sine rule. It's important for you to always decide which rule is necessary first. Okay, try this one here. Okay, that one was cosine rule for sure because we had side, angle, side. There's cosine rule, there's the setup. Again, we're looking for this side, therefore the angle and the cosine that goes in is the one across from it, 62. Solve it like that. Make sure you know how to do it on your calculator. You're going to do square root of all that to get BC. Okay, try this one. Okay, this one was side, 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 therefore cosine rule as well. And this time we're looking for an angle because it says find angle A, so we're going to use the angle formula for cosine rule. And here, remember again, if we're looking for angle A, then the thing we're subtracting is side A. So here's angle A, so 18 is the one that goes here, minus 18. And then the other sides fill in the rest. This, again, make sure you know how to punch in one step on your calculator. So you do an inverse cosine of all of that. Okay, try this one. Okay, clearly cosine rule as well. We have side, angle, side, cosine rule, set it up like this. Check your work carefully, and let's check our answer as well. Next one, try this one. Okay, so there's the diagram. This one was an angle, angle, side triangle, therefore sine rule. And notice we need to begin by finding angle P, and then sine rule applied, and you get the answer. All right, how about this one? Okay, in this one, it's going to be cosine rule, because we have this diagram here. If you drew the two towns due north of each other like this, another town is east of them, and the distances are given, you have this triangle where you have side, 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 and you're looking for an angle. So side, side, side is cosine rule, looking for an angle, set it up, there you go. Check your work carefully right there. All right, how about this one? Okay, this one is a combination of different things. We do cosine rule first, and then we can use sine rule to find another angle. So you could have used cosine rule again, but once you have enough angles and things to use sine rule, it's often easier to use sine rule. So follow the work here, check how you did as well. And finally, this is a more typical problem. Let's see if you can solve this. Okay. Here's, this is typical problem, I said, because it involves all of our trigs. So first we're going to use tangent to find the height of this building, and there's that. So the height of that building is 29.9. Try the same thing here, find the height of that building. Well, we can use tangent again, and we get the height is 8.56. Next, we need to find the distance between the buildings, this line. So we're looking at this triangle. So first, we'll begin by finding this angle where the person is 130, just doing 180 minus those. Then we can use Pythagorean theorem twice to find those pieces, and then finally cosine rule to finish it off once we have that triangle. Good problem, combines everything. Great work.